Hey guys, myself Shivang this side, working as a DevRel engineer at Router Protocol, and welcome to the first video of writing, building and deploying a Tic Tac smart contract on Router Chain. So in this video, as the name suggests, we'll be writing, building and deploying a smart contract related to a Tic Tac game on Router Chain. It will be a multiple part series tutorial, and we'll be just writing smart contracts. At the end, we'll be deploying that particular smart contract application to Router Chain directly. So let's get started. So for this entire particular tutorial series, we'll be referring Router Academy. I have already created the documentation part for it, and so that it just get easier for you guys. So just directly go to academy.routerprotocol.com in case you haven't, and click on the Learn Now button. After clicking on it, you will be just directed to the courses section of Router Academy, where all the documentations have been written. So just click on Start Learning. After that, go to Router Chain part, and under that just go to Building on Router Chain, and after that just go to module 8, which is building a Tic Tac contract on Router Chain. This module number 8 contains all the documentation which is required for building this particular smart contract. I have already created a repository which you guys can refer to, and it gets easier for you guys, so you can refer it. Now I'll just copy this particular link and open up the repository. I'll paste it in my browser. And yeah, as you can see, the repository has been opened up. Now just go to the code button and you can just directly copy paste the cloned URL link, and I'll close this tab. I have already opened my VS Code editor, and I have already cloned the repository, and meanwhile you guys can also clone it. In the meantime, I'll just give you a quick walkthrough of the entire file folder structure and how everything is being organized in a CosmWasm and Rust architecture. So as you all know, Router Chain is a Cosmos SDK built chain. So any smart contract or decentralized application you built on Router Chain is built using Rust and CosmWasm. And to integrate the router part, you will be needing Router Wasm bindings. So as we clone this particular repository, we get 4 to 5 folders and couple of files. README file is a basic README file which I have created for your reference. Cargo.toml file, it basically contains all the dependencies of our project. For example, in Node.js, we have package.json. Similar is the utility of cargo.toml in a Rust-based project. Git ignore is simply used to ignore some of the folders which we don't want to push in our GitHub repository. Scripts folder contains 2 files, build.sh and deploy contract.sh. These files we won't be referring right now. These files would be more utilized at the last part of our tutorial series, which is in the deployment aspect. So I'll close these files. Schema, it basically contains the JSON files for some of our enums and some of our functions which we have written in our contract. We'll be covering up it later. Now the main part of our series, the main part of our code, it comes under the contract section. Just directly go to the contracts part. Under this, you will be seeing 2 folders, 2 directories, Counter and Tic Tac. Counter is a sample project which you directly just get whenever you're building a Rust and CosmWasm project. It is the default one for CosmWasm. So it is of no need right now. The main folder which we have to use, the main folder which we'll be using in the entire tutorial series is Tic Tac. So just directly go to it. Under this, you will be seeing 3 major components: src directory, cargo.toml and a readme. So again, readme is a simple basic file which I have created for your reference. Cargo.toml is the main core file which basically contains all our dependencies and all our packages which we have installed. As you can see, create type and CosmWasm std, which is a standard CosmWasm library which we'll be using extensively in our entire tutorial series. Schema rs, CosmWasm storage plus, CosmWasm 0, CosmWasm 2, CosmWasm crypto, and many other dependencies which we'll be exploring in our further parts. And if I go under the src directory, I have a lot of files here, roughly 7 to 8 files I'm having. So the first file is contract.rs, another file is data.rs, another file is error.rs, and another one is execution. Similarly, we have lib, message, query, state, and tests. all these files are basically interlinked to each other, and the main core file, or you can say the starter file for a project, is contract.rs. Contract.rs, if I talk about in a layman language, it basically is a file which summarizes everything in a concise way. It is the main file which you will be starting with. The first file which you will be starting with writing the code is contract.rs. So as the name suggests, we'll be just starting with this file only. So I'll be just going to contract.rs. I'll just shorten the size of my terminal a bit so that it is more clear to you guys. Alright. So here's the entire documentation which I've created on Router Academy, which you guys can definitely refer to. I'll be referring it and I'll be explaining each and every component to you with the help of this. So moving on to contract.rs, the first file of our project. If I talk about these commands, right, these import statements, basically these are some of the basic import statements which I have created in my file. These are the dependencies or the packages which I am using in this particular file. As you can see, CosmWasm std, it is basically the package. CosmWasm std is a package, and toBinary is a particular function which I am importing from that package. Similarly, cw2 is a token package which I am using from CosmWasm standard library, and the functions which I am using from this are get contract version and set contract version, which I have just used in the instantiate function. These are basically used for getting the version of your smart contract as well as setting a version for your smart contract, right? Similarly, we have query games which we have which we are using from the different files we have created. As you can see, we are importing different functions, different components from different files. Like from errors, we are using contract error. From execution, we are using try except, try invite, try play, try reject. For basically, as you can see, we have written use create state games count. So what is create? What is use? Whenever we want to use any function or any component we have created in different file, we have to write a statement like use create the file name the particular function we want to use in our current file. Like in JavaScript, we have import anything from anything. Let's say I'm using React. I'm building something on React. So what I usually write is, I'll just write a sample for you guys here. Import React from React, right? This is usually what I write. Similarly, for the name convention for the purpose of different language, like right now we are working in Rust, what do we do usually is we write something as use, and create is a package manager which helps us in fetching different files, different functions from different places to a single file for basically importing purposes. Like I can use create, similarly I can use errors, similarly I can import, let's say, contract error, which is again the first line of our code, and yeah, I've used it. So this is the utility of create package manager. Alright, now moving a bit down, contract name and contract version. This is a basic file naming convention. Contract name is the name of our contract as the variable suggests, and you can see the name which we have kept here. Contract version justifies and specifies the version of our smart contract which we are using currently. Now we'll be exploring the particular functions which we have created in contract.rs file. If I minimize everything for you, so you can see we have broadly 3 functions here, right? Alright, cool. Yeah, so we are having 3 major functions in contract.rs. As you can see, instantiate, execute, and query. Now these functions are really simple, and as the name suggests, it is pretty obvious what they are doing. Instantiate is the function which is the first function which we create in contract.rs. It is the function which runs the foremost whenever your contract is deployed and called upon, right? Basically the first function to be run and called upon is instantiate, whatever you define in it. After that, coming up to the execute, we'll be deep diving into the functionality in a while. After that, coming up to the execute function, what it does basically, execute function consists of the main core functionality of your smart contract, right? Whatever you are doing in your smart contract, what are the different states, how you are interacting with it, what is the core functionality happening in it, is contained within the execute function. Similarly, query function is nothing, it's a very simple function. It is basically used to define, or basically used to read the values or read any data which is present in your smart contract. It basically is used for reading purposes, not for writing or anything. I hope this is clear. Now moving on a bit, we have covered these aspects. Now jumping on to the instantiate function, deep diving into a bit. Alright, as you can see, I have 4 parameters here: deps, env, info, message info, and instantiate message. After that, I have defined std result, response, and I have written majorly 3 lines of code under this function, which are set contract version, games count dot save, and okay response, which basically gives a response, right? Now, first line, basically the set contract version, it basically sets the version of our contract whenever our contract is deployed. The version of our contract is used to be specified, it has to be defined, right? And that is being done using this function. Similarly, games count dot save, games count is a variable which you can see we have created in the states file, right? State.rs. If I just go to this file, you can see game count is something which we have created here. I'll just search it here. Alright, cool. As you can see, yeah, games count is something, it's a state which we have defined in our state.rs file. As the name suggests, as I previously explained, state.rs is used to define the states in your smart contract. So what it does is basically the number of games users are playing, the number of games players are playing, games count, it is a constant which keeps a track of it. So in the instantiate function, we are defining it so that whenever our contract is deployed and called upon first time, since then it just keeps on tracking the number of games being played, right? And lastly, the last line of our code within the function instantiate is defined. It gives a response that okay, the contract for the contract version for this particular smart contract has been set, the games count variable has been saved, and it is running successfully, and yeah, everything is okay. So this is all about pub func instantiate. Now moving on to the second function, which is execute. I'll zoom it a bit, and yep, cool. Similarly, in execute function, we have defined 4 parameters. So you can see deps mute, env, message info, and execute message. As the name suggests, it is executing the core functionality of our smart contract. You can see I have imported a particular variable, particular parameter called as execute message here. If I go to the top, what is execute message? You can see I have imported it from the message.rs file. If I open message.rs file, you can see I have created different structs and different enums here, right? I have created a struct called instantiate message, which I have called upon in my instantiate function here, as well as I have created another enum called as execute message. Now what is the difference between struct and enum? A really simple concept. Struct is a simple struct, it is a simple function which can be called many times at different places. Enum is a type of function, or it is a something which contains different functions in it, sub functions you can say. Like for the sake of this functionality, execute message, I need different types of functionalities within it, right? So I have created a function called invite, reject, accept, play, and yeah, I have broadly created these 4 functions within it. So this is about execute message enum. Similarly, I have different enums here: query message, which we'll be using in the query function, as well as query key, again which we'll be using in the query function in contract.rs. So yeah, as you can see, I am using a match variable, which is a simple concept in Rust, and I have a result function here, a result method, which basically catches the response and If the response is not valid, it displays the contract error. So you can see I have defined these 4 things here, right? What are they? If I go to message.rs, I have defined 4 functions here, right? Invite, reject, accept, and play. What does invite contain? Invite basically contains the coordinate COORD which I have defined, and the opponent. It basically contains the coordinates of the opponent as well as the string, probably the name of your opponent or anything you can define. Similarly, reject, it basically consists 3 parameters: as host, opponent, and game ID. Game ID, the particular game ID in which you are in, and opponent, again the name of your opponent or a string which is used to define your opponent at that particular game. And as host, it basically defines that are you a host in this game or not. That's why we have used a bool boolean data structure here. Similarly, accept, for it we are also having coordinate which defines the coordinate of the person who is accepting the game challenge. And host, okay, is this person host or not? Okay, and we can define this person's name. And we are having game ID, that what is the game ID of this particular game. Similarly, you can see in reject also we are having game ID, because reject and accept is something which go parallelly in hand. And lastly, we have play, whether the person accepts it, then the user can start playing. As you can see, we have 4 parameters again here: as host, chord, opponent, and game ID. Again, game ID just defines the particular ID of that game. Opponent defines the name of the opponent or just something to store in the string. Chord basically defines the coordinates, and as host we have discussed about it a few seconds ago. And yeah, if I go back to my contract.rs file, you can see I have created a match variable here called MSG, and under that I have imported all of the functions which are defined in the message.rs file. Now you can see this. If you are not aware of what is match, what are these variables, I'll be linking down a Rust cookbook below in the description box. You can just directly refer to it. It's a pretty simple concept, and I have used all these functions here. After that, I am also using a particular function called try invite, try reject, try accept, and try play. Now what's happening is, under play I have defined all the parameters which possibly a user can use to play the game. Now after that, I also have to define the core functionality, right? That what is actually happening in the game. So for that, as I discussed previously, the file which we'll be using for defining the core functionality for the main execution tasks of our smart contract, it is called as execution.rs. Now coming back to this file, execution.rs, we have broadly 4 functions here: try invite, try reject, try accept, and try play. We'll be deep diving into these functions in the later video, because this video would get really long. And as you can see, in my execute function I have imported all of these functions, right? Try invite, try reject, try accept, try play, to later on to basically increase the functionality. And that's about the execute function of our smart contract in contract.rs file. Now jumping over to the last function of our contract.rs file, it is basically query function, right? As the name suggests, we previously discussed, it basically is used to query the particular data in your smart contract, and it is used for reading functionality. It is never used for writing something, or never used for anything related to write operations, but it basically justifies that you can read your data. So similarly, we have defined 3 lines of code here, you can see, and a standard result library of binary. We have defined 3 functions, basically get, contract version, game, and games, right? Under that, we have been using 2 binary functions, which you can see we had defined above using the CosmWasm standard library. And again, it is just performing simple read operations. You can see query games, query game, and to read a particular game, if you want to read the data of a particular game, that what's happening in the game, it can be written, it can be seen via, it can be read via the query game function. If you want to see the data of multiple games, you want to read what's happening in multiple games, you can just directly refer query games. Similarly, if you want to see the version of your smart contract, you can directly use get contract version. And all of this have been defined above in the query file, which is query.rs. As you can see here, we have defined a function query game and query games. Now again, what is deep diving happening in this particular file, we'll be again covering it up in the later videos. Now moving back to the Router Academy part, the documentation part, what is actually happening. We have covered all of these concepts related to contract.rs file, and moving on to the data.rs file. Alright, I'll just close these files for a while and save this one. Data.rs basically is a simple file which we have defined here. It contains a really simple function called as game response. Now what this game response function is doing, it basically takes a response for each and every game. It basically collects the response, collects the data for every game. That's why we have defined the name of the file as data.rs. Now what it collects, basically it collects the game, the data of the game, the data of the host, the addresses of the host, and the addresses of the opponent, the person who is hosting the game and the person who is acting as an opponent in that particular game, right? And you can see that we are using variable game here and variable address here. So address is something which we are directly importing from the CosmWasm standard library, and the variable game, you can see we are directly importing it from state.rs file. As you can see in line number 5, we have defined via the create package. If I go to create state.rs file and I search game here, okay, it has been defined a lot of times here. Yep. So basically this is the struct which we will be using, the struct game. Again, we'll be deep diving into state.rs file in the further videos. We have been using this state, the function defined within state.rs, the struct defined within state.rs called game in our data.rs file. And yeah, that's basically a bit about what's happening in the data.rs file. Now jumping over to the third file of our project called as errors.rs. So what it is doing, basically, errors.rs file, as the name suggests, it's again a really simple file. It basically contains all the different types of errors you can possibly get in your smart contract, right? Whenever you are building a smart contract, you can define custom errors which you can add to the places where you feel you can get some kind of error, right? So within this file, we are defining some of the custom errors which we'll be using at different places for our own use, right? As you can see, we are using unauthorized, that okay, this particular wallet address is something which is not authorized to host the game or anything like that. We can use it for cannot start game, that okay, this particular wallet address or this user cannot basically start the game already in progress. A really simple error, as the name suggests itself, that game is already has started. The game already consists of a host as well as an opponent, so no one can enter it. And game not found, it basically is very very useful, because in our state.rs file we are using game ID, right? Whenever the game ID doesn't match, so we have to use a function, we have to use a particular error, we have to use a method which displays to the user that the game has not been found. Similarly, invalid game is something which is used to declare that the game ID is not valid. Similarly, we have coordinate already played is something that which is used to declare to the user that this particular coordinate has already been played and you cannot jump over to this coordinate. Like in Tic Tac game, we have 9 cells, right? So if a particular cell, let's say cell 1 has been played, so there has to be a method defined which tells the player that this particular cell has been played, it has been blocked, and you cannot go to this one. Similarly, we have turn already played, invalid coordinate, and invalid received funds. And yeah, that's a bit about errors.rs file. So yeah, this was a bit about the first part of our video series called as writing, building and deploying smart contracts on router chain. And I hope this was a really good one and you will be able to write more smart contracts on router chain. And let's meet in the second part. Thank you.